Sometimes, to understand how life endures, we must first witness how it ends. Welcome to the Lantern's Glow, where we trace the great threads of time, not only to ask where we come from, but to better understand why we are still here. In this episode, we face one of nature's most haunting truths, that life, wondrous, stubborn, resilient, is sculpted as much by endings as by beginnings. Earth has known 5 great mass extinctions, each one brought upheaval, silence, change, and yet life returned, not as it was, but as something new. Without those collapses, we might never have come to be. So, what forces shaped those turning points, and what echoes of them remain today? To tell this story, we've gathered voices from across the ages, fossil records, evolutionary patterns, scientific insight, and shaped them with the quiet clarity of artificial intelligence. But the voice you hear and the questions we ask remain deeply human. AI is not the speaker, it is the compass, drawing from our records, refining our path through time. This episode is not only about extinction, it is about persistence, about how, even in the darkest hours, the flame of life never fully vanished, and how, even now, in an age some call the 6th extinction, we may yet choose to listen, to learn, and to act. So breathe in, and when you're ready, come walk with me through deep time. Let's look back, not just at what was lost, but at how life adapts, transforms, and finds a way to begin again. This is the Lantern's Glow, and this time we walk the edge of extinction to glimpse what life might still become. All is one.
Okay, let's talk about the end of the world, 5 times over.
Sounds dramatic, but it's accurate. The history of life is punctuated by collapse. These mass extinction events wiped out between 70 and 96% of species. Fast, in geological terms.
So, let's go back to the first mass extinction. What happened?
The first great extinction, the Ordovician Silurian extinction, was 443 million years ago. 86% of species became extinct. It was the end of the Ordovician period, a time when most life was still aquatic. The continents were clustered together in the southern hemisphere, and biodiversity had exploded in the oceans. Trilobites, brachiopods, graptolites. Oceans teemed with strange life forms, many of which no longer exist.
So Earth was kind of like an alien aquarium back then.
Exactly. And then, over the course of roughly 1 million years, around 85% of marine species vanished.
That's staggering. Do we know what caused it?
There are a few culprits. The leading theory involves a sudden and severe global cooling event. Glaciation on the supercontinent Gondwana triggered a massive drop in sea levels. As ice sheets grew, vast, shallow marine habitats were drained.
So it wasn't fire and brimstone. It was ice.
Yes, and ice can be just as deadly. Many marine organisms lived in warm, shallow seas. When those seas retreated, they had nowhere to go. Ecosystems collapsed.
But it wasn't just the cold, was it?
No. There's evidence that a second punch came not long after: global warming. After the glacial peak, rapid melting occurred. Sea levels rose again, but the chemistry of the oceans had changed. Anoxic conditions, where oxygen becomes depleted, set in. Many species that survived the initial cooling didn't survive the aftermath.
A climate whiplash.
Precisely. Some researchers have even proposed a gamma-ray burst from a nearby supernova as a factor, stripping away the ozone layer and allowing lethal UV radiation to reach Earth's surface.
That sounds like science fiction.
The point is, mass extinctions aren't caused by a single villain. They're perfect storms, several stressors acting together to push ecosystems past their tipping points.
So let's paint the picture. The oceans, once teeming with life, are now eerily quiet. Coral-like creatures gone. Trilobites reduced. Graptolites, which once floated in vast colonies, blink out entirely.
It's a hard reset, but it also set the stage for something new. The Silurian period that followed saw the rise of jawed fish and eventually life creeping onto land.
That's the pattern, isn't it? Death, and then transformation.
That's how it seems. Mass extinction is brutal, but it also creates ecological space. Nature abhors a vacuum. When niches open, evolution gets to work.
There's something eerie but hopeful in that.
It's one of the great paradoxes of deep time. Catastrophe and creation are intertwined.
So as we move forward from this first great extinction to the next, we carry that idea with us. Every collapse is also a beginning.
And sometimes, it's only by looking back, 443 million years back, that we understand how fragile and adaptable life really is.
Following this was the late Devonian extinction.
375 to 360 million years ago.
Now here's a curious one. Unlike the dramatic punch of an asteroid or the suffocating horror of a planet-wide firestorm, this extinction was more like a slow collapse. Drawn out over 15 million years, it quietly erased around 75% of species, especially in the oceans.
15 million years? That's like extinction in slow motion.
Rather than a single catastrophic event, it was a cascade. Drawn-out stress, failure, and finally, collapse. Coral reefs were the most affected. In fact, reef building didn't recover for over 100 million years.
That's staggering. So what went wrong? What made the seas turn deadly?
The causes are still debated, but the evidence suggests a dangerous combination of factors. One of the most compelling is eutrophication. That's when too many nutrients, mainly phosphorus and nitrogen, are introduced into marine systems.
Like what we see in today's agricultural runoff?
Precisely. Algal blooms exploded. These algae consumed massive amounts of oxygen as they decayed, creating hypoxic or anoxic zones, dead zones. In these regions, nothing could survive. The water became poisonous.
So the ocean was choking itself.
In a way, yes. And this wasn't local. These oxygen-depleted zones spread across vast stretches of seafloor. Fish populations declined. Reef ecosystems collapsed. Filter feeders and bottom dwellers were hit especially hard.
Was that the only factor?
Not at all. Another key suspect is volcanic activity. Large igneous provinces may have triggered global warming, acid rain, and further destabilized the climate. Some evidence points to increased carbon dioxide levels, leading to ocean acidification, just like we see today.
There's that unsettling parallel again.
It gets more interesting. The Devonian was also a time of significant biological change. Plants were colonizing land in a big way, developing roots, leaves, even vascular systems. With them came soil formation and large-scale photosynthesis.
You're saying trees might have helped trigger the extinction?
Indirectly, forests pulled CO2 from the atmosphere, which may have led to cooling. But as roots grew deeper, they broke down rocks, which accelerated weathering. This weathering released more nutrients into rivers. Guess where they ended up?
The ocean.
Exactly. More nutrients, more algae, more dead zones. A feedback loop.
It's like the planet was reshaping itself, and in doing so, accidentally poisoned its own seas.
A beautiful, but brutal irony. Evolution doesn't look ahead. It adapts in the moment. And in the Devonian, plants were winning on land, while life in the oceans paid the price.
That's an extraordinary tension. Terrestrial life beginning to thrive, just as marine life starts to collapse.
Yes. Some researchers even refer to this as Earth's first real taste of a planet-wide ecological imbalance, caused not by fire or ice, but biology itself.
That feels hauntingly relevant.
It should. Many scientists draw parallels between the late Devonian and today's environmental crisis. The creeping pace, the oxygen loss in our oceans, the runoff from land, the slow disappearance of coral reefs. Sound familiar?
It does. And it's uncomfortable to realize that we've seen this film before. Only this time, we're not just the audience.
We're the producers.
So what kinds of life made it through?
Small, adaptable species. mostly those that could cope with low oxygen levels. Many of the armored fishes that had dominated the seas disappeared, but their extinction opened evolutionary space for ray-finned fishes and early tetrapods.
The ones that would eventually crawl onto land.
Precisely. So even in this slow catastrophe, evolution didn't stop. It rerouted, and life, in its stubborn way, continued.
So the Devonian ends not with a bang, but with a suffocating silence and the quiet preparation for something new. Which, as we'll see, is a theme that repeats again and again. From collapse, new beginnings.
And if there's one final takeaway from the Devonian, it's this. Not all extinctions come as a sudden impact.
That feels familiar. Like climate change today, rising temperatures, shifting ecosystems, but all happening in a kind of global murmur rather than a shout.
Exactly. And that murmur can be just as deadly. The Devonian teaches us that even gradual shifts can reshape the planet. It's a story not just of what we've lost, but of what we risk repeating.
Which is why this isn't just history, it's a warning, a long echo ringing through time that we'd do well to hear. And before we go further, take a breath. Because this is where the numbers get truly staggering.
Because now we arrive at the Permian Triassic extinction.
252 million years ago, the Great Dying. It's the most severe mass extinction event in Earth's history. That name alone, the Great Dying, it feels biblical.
And it was. Forests collapsed. Coral reefs disappeared entirely. Life on Earth came terrifyingly close to ending.
What caused something that catastrophic?
The evidence points to an unimaginable series of volcanic eruptions in what's now Siberia. Over hundreds of thousands of years, they formed a vast igneous province known as the Siberian Traps, literally millions of cubic kilometers of lava erupting onto the surface.
That scale is hard to picture, like continents drowning in lava.
More than that, the lava wasn't even the most dangerous part. As it tore through sedimentary rock, it released huge amounts of greenhouse gases, CO2 and methane, into the atmosphere. Global temperatures surged by up to 8 to 10 degrees C.
That's beyond climate change. That's climate collapse.
It caused ocean acidification, reducing marine biodiversity. Oxygen levels plummeted. The oceans became anoxic, meaning large swathes were completely devoid of oxygen, essentially underwater dead zones.
So both land and sea were suffocating.
Yes, an acid rain likely followed, stripping vegetation and disrupting ecosystems further. Combined, these factors created a chain reaction, a planetary death spiral.
Was there any refuge? Any corner of the planet untouched?
Possibly some high-latitude regions or isolated ecosystems, but the devastation was global. Even the insects, which usually fare better in extinction events, suffered major losses.
What was life like after?
Bleak. The post-extinction Earth was a desolate place. For millions of years, biodiversity remained low. Recovery was slow. Forests took time to regrow. Coral reefs didn't return for 10 million years. Entire ecological niches were just gone.
And yet, somehow, something survived.
Yes. The survivors tended to be generalists, organisms that could handle a range of conditions. One of the most famous is Lystrosaurus, a pig-sized herbivore with a squat body and a stubby face. Fossils of it have been found across what is now Africa, Asia, and Antarctica.
Lystrosaurus, Earth's first great colonizer?
In a way. It dominated the land for millions of years after the extinction, one of very few vertebrates to thrive in that aftermath.
It's incredible to think that everything alive today is descended from what made it through that bottleneck.
Absolutely. The Permian Triassic extinction was a genetic purge. Every species alive now comes from survivors of that planetary reset.
And I can't help but notice the causes of that event, greenhouse gases, warming, acidification, they sound eerily familiar.
Many scientists have noticed too. That's why this extinction gets talked about a lot in climate change discussions. It's the closest analog we have for what runaway global warming can do.
So when people ask, what's the worst that could happen? The answer is in the rock record.
Exactly. The Great Dying shows what happens when Earth's natural systems spiral out of balance. And the parallels are unsettling.
Because unlike volcanic eruptions, our emissions aren't accidental. They're chosen.
That's what makes this moment in time so pivotal. We're living in a period of intense environmental change. The question is whether we learn from history or repeat it.
There's also something deeply philosophical here, a kind of cosmic vulnerability that the Earth, so massive, so enduring, can teeter so close to oblivion and then pull itself back.
That fragility is humbling. And yet, life did return. From that devastation emerged new lineages, early archosaurs, forerunners of the dinosaurs, and eventually mammals.
So again, we see that same pattern. Death gives rise to new possibilities.
But it comes at a price, and the Great Dying was the steepest price life has ever paid.
You know, this talk of runaway warming, atmosphere collapse, and planetary tipping points, it reminds me of something else.
What you just described, atmospheric collapse, CO2, acidification, the unraveling of life, Venus?
Yes, Venus is Earth's evil twin. Roughly the same size, same mass, even formed from similar planetary ingredients. But while Earth became a cradle for life, Venus turned into an inferno. And understanding why might be one of the most important lessons we have.
I read somewhere that Venus might once have had oceans.
That's a leading theory. For the first few 100 million years, it could have been surprisingly Earth-like. Liquid water, clouds, perhaps even mild weather. But something tipped the balance. A runaway greenhouse effect.
So it's not just hot. Venus is the hottest planet in the solar system.
Hotter than Mercury, despite being farther from the sun. The average surface temperature is around 464 degrees C. That's hot enough to melt lead, and it stays that way, day or night, pole to pole.
And the atmosphere? What's it made of?
Mostly carbon dioxide, with thick clouds of sulfuric acid. The pressure at the surface is more than 90 times what we experience on Earth. It's like being 900 meters underwater. Add to that acid rain and a sky that never sees blue, and you've got a planet that feels more like myth than science.
But what made it turn? What went wrong?
We don't know exactly, but there's strong evidence that volcanoes played a major role, releasing enormous volumes of CO2. Once the greenhouse gases started trapping heat, the oceans evaporated. And here's the twist. Water vapor is itself a greenhouse gas.
So the more it heated, the more water turned to steam, which made it heat even more?
Exactly, a feedback loop. Eventually, all surface water was lost to space. The carbon cycle collapsed, and there was no way to cool down. Venus became a permanent pressure cooker.
That feedback loop sounds familiar. Are we in one now?
Not at Venusian scale, but we're seeing signs. Arctic permafrost melting, releasing methane, warming oceans, forests that once absorbed CO2 now burning and releasing it. These are early echoes of a Venus-like spiral.
It's strange to think of another planet as a ghost of our possible future.
That's exactly what it is. Venus isn't just a scientific curiosity, it's a cosmic warning. A monument to what can happen when atmospheric systems destabilize.
And in a way, it's sobering. Because Venus didn't have industry, or coal plants, or SUVs.
No, it happened through natural processes, volcanoes, orbital shifts, solar radiation. We, on the other hand, are forcing similar outcomes, but faster and knowingly.
So if Earth were to tip, it wouldn't take millions of years.
It could happen in centuries, and once those tipping points are crossed, there's no turning back. The planet doesn't owe us a safe climate.
But that's what makes this moment different. Unlike Venus, we know what's happening. We have the tools to stop it.
That's the hopeful part. Knowledge is our advantage, but awareness isn't enough. We need action.
It almost makes me feel like we're standing at a fork in the cosmic road. Earth or Venus, recovery or ruin.
That's a powerful image. Two sister planets, one alive and teeming, one scorched and silent.
So we ask ourselves, which one do we want to become?
So let's take a breath. We've traveled from ancient oceans to volcanic hellscapes, and even crossed space to glimpse a warning in the sky. What have we learned so far?
We've seen that extinction isn't rare. It's woven into the fabric of life on Earth. 5 times now, ecosystems have collapsed, sometimes slowly, like in the Devonian, sometimes all at once, like the Great Dying.
And each time, the causes were different, but the outcome was the same. Life changed forever.
In the Ordovician, it was global cooling, glaciers pulling down sea levels and destroying shallow marine habitats. Then the Devonian, where new plant life on land fed the oceans too many nutrients and triggered suffocating dead zones.
Then came the Permian, the worst extinction in Earth's history. Triggered by volcanoes and amplified by greenhouse gases, it turned the entire planet hostile to life.
And we can't ignore the resonance with today's world. Our oceans are warming, coral reefs are bleaching, greenhouse gases are rising, faster than at almost any point in Earth's history.
And then there's Venus, the world that didn't pull back from the brink.
No, it didn't. A cosmic mirror showing us what happens when a feedback loop runs wild. Venus is the endgame of climate gone unchecked.
But Earth isn't Venus. Not yet.
And the fact that we can have this conversation at all, that we can learn from geology, from atmosphere, from space, that's what gives us hope.
So let's keep going, because the story of extinction, it's not finished yet.
So, what came after the Great Dying? Was it peace and quiet for life on Earth?
Not quite. Life did recover, but only for a time. Around 201 million years ago, Earth faced another reckoning, the Triassic-Jurassic extinction. It cleared the biological stage once again. About 80% of all species disappeared.
That's huge. But it gets overshadowed by the next one, the one that wiped out the dinosaurs.
Understandably. But this event was crucial. It reshaped the evolutionary landscape. It eliminated many of the dominant species of the time and opened the door for one of Earth's most iconic dynasties, the dinosaurs.
So what was Earth like before the extinction?
The supercontinent Pangaea still held together, one massive landmass stretching across much of the planet. The climate was hot and seasonal, with large inland deserts and intense monsoons. Reptiles and amphibians dominated.
While the giants roamed the Earth beneath their shadows, a new chapter quietly stirred. Morganucodon, no larger than a mouse, was writing the first lines of the mammalian story that would one day lead to us.
And then something massive disrupted the balance. The likely culprit? A chain of volcanic eruptions tied to the opening of the Central Atlantic magmatic province. As Pangaea began to rift apart, enormous fissures opened in the crust, spewing lava and greenhouse gases.
So another spike in CO2?
A massive one. CO2 levels soared, global temperatures rose rapidly, and this time it wasn't just heat. The chemistry of the oceans shifted. Acidification once again eroded the base of marine ecosystems.
You'd think Earth would have learned by now.
But Earth doesn't learn. It reacts. Feedback loops, like methane release, CO2 surges, and ocean stagnation, are part of the planet's deep systems. When they go out of balance, they tip everything else with them.
So, what did this mean for life?
A biological bottleneck. Giant amphibians like Metaposaurus, armored reptiles like etosaurs, and marine creatures like ammonites vanished. But a few small, scrappy dinosaurs, like Chalaphysis and Plateosaurus, managed to cling on. When the dust cleared, they found an empty world ready for the taking.
What allowed them to survive when others didn't?
Adaptability, for one. Their physiology allowed them to thrive in extreme conditions. They could lay eggs on land, manage energy more efficiently, and quickly colonize open ecological niches.
So the extinction event didn't just end an era, it launched a new one.
Precisely. We call this evolutionary release. Remove the dominant competitors, and surviving groups can expand, diversify, evolve into forms that were previously impossible.
It's a kind of forced creativity. Nature starting from scratch.
Yes. Extinctions don't just erase, they also rearrange. They prune the evolutionary tree, but in doing so, they allow new branches to grow.
It makes me think about today. If our actions are changing the climate, driving extinctions, what comes next?
That's the haunting question.
And sometimes all it takes is a single extinction window to flip the board.
Exactly. The extinction at the end of the Triassic was the prologue to the age of dinosaurs.
Let's continue this journey to the event that reshaped the planet once again and ushered in the rise of mammals.
Yes, the Cretaceous-Paleogene extinction, one of the most dramatic days in Earth's history. Let's dive in.
So here we are, the most famous extinction of them all, the one that ended the age of dinosaurs, the Cretaceous-Paleogene extinction.
Yes, 66 million years ago, life on Earth changed in a matter of hours. This was a global cataclysm unlike anything before it. The end of an empire and the beginning of another.
Let's set the stage. What was Earth like before the asteroid?
It was rich, diverse. Dinosaurs ruled the land. Flying reptiles soared through the skies. The oceans teemed with ammonites, marine reptiles, and vibrant coral reefs. It was an ecological golden age.
And then, the sky burned.
A mountain-sized asteroid, about 10 to 12 kilometers wide, slammed into the Earth near what is now the Yucatan Peninsula in Mexico. The impact site is called the Chicxulub crater.
The scale of destruction. It's almost beyond imagining.
Within seconds, the asteroid unleashed energy equivalent to billions of nuclear bombs. A fireball vaporized everything for hundreds of kilometers. Shockwaves rippled through the crust. Megatsunamis surged across oceans.
But it was what came after that truly ended the world, wasn't it?
Exactly. Dust and aerosols blasted into the stratosphere, veiling the Earth. Sunlight vanished. Photosynthesis stopped. Temperatures plunged. Ecosystems collapsed. This was the true killer. A nuclear winter.
A world plunged into shadow. And the dinosaurs?
Gone. All non-avian dinosaurs perished, along with 75% of all species on Earth. Pterosaurs, marine reptiles, ammonites, vanished.
It must have been like watching the world fall silent.
It was the end of an era 160 million years in the making.
Wait, what? 160 million years? That's how long the dinosaurs ruled the Earth? And we, Homo sapiens, have only been around for just over 300,000? That's staggering.
But hey, The dinosaurs didn't have a space program. We've barely blinked in geological time, and we're already reshaping the planet.
We'll come back to that in another episode when we look at how our population exploded and what it means for the future.
But for now, in the ashes of extinction, new life stirred. Birds, mammals, frogs, lizards, insects, creatures that could hide, adapt, endure.
Why did they survive when the dinosaurs didn't?
Likely a combination of traits: smaller body sizes, burrowing habits, flexible diets, faster reproduction. The mass extinction didn't select for strength, it selected for resilience.
And so begins the rise of mammals.
Yes. In the wake of devastation, mammals diversified rapidly. Within 10 million years, we see the first large mammalian herbivores and predators. The seeds of everything from whales to primates, including us, began here.
It's strange to think that without that asteroid, humans might never have evolved.
Strange and humbling. Our existence is written in the ashes of that day. In a sense, we are the children of catastrophe.
There's a poetry to it. Out of fire and darkness, a spark of something new.
And now, with that knowledge, we carry a responsibility to understand how quickly life can be undone and how precious it truly is.
So that was the fifth extinction. Violent, abrupt, and world-altering. And yet, it gave rise to the age of mammals.
The last 5 extinctions were caused by natural events: asteroids, volcanoes, atmospheric shifts. But the 6th, that one is different.
Because this time, the asteroid is us.
So now we arrive at the present, a moment unlike any other in Earth's history. Not because extinction is happening again, but because it's being driven by a single species: us.
Welcome to the Anthropocene, a proposed new epoch where human activity is the dominant force shaping the planet. And increasingly, that shaping has come at the expense of other species.
Scientists say extinction rates today are 100 to 1,000 times higher than the natural background rate. That's not just a blip. That's a planetary crisis.
We're losing species faster than at any point since the dinosaurs vanished. Amphibians, insects, birds, mammals, all declining. And what's truly alarming is how widespread the causes are.
Let's list them: deforestation, habitat loss, pollution, invasive species, overhunting, overfishing, urban sprawl,
And of course, climate change. Warming oceans, rising seas, acidification, extreme weather, all accelerating the unraveling of ecosystems.
But this time there's no asteroid, no supervolcano. It's not nature turning on us, it's us turning on nature.
Exactly. Elizabeth Kolbert, in The Sixth Extinction, puts it powerfully. Humanity isn't just another species. It's a geological force.
She starts her book in Panama at the Frog Hotel, a safe house for amphibians that are going extinct because of a chytrid fungus. And yet that fungus likely spread globally because of human movement.
A single pathogen, accelerated by global trade, wiping out species by the hundreds. It's a grim metaphor for our impact.
And it's not just frogs. There's the great auk, the American mastodon, the Baiji river dolphin, extinctions we witnessed.
And many more we didn't. Species disappear every day that we'll never even know existed.
So is this truly a mass extinction, or just a tragic side effect of progress?
That's the uncomfortable truth. It's both. Our industries, our expansion, our hunger for energy and resources, it's reshaping the biosphere.
And if current trends continue, scientists believe we are on course for another big 5-level extinction. But unlike the others, this one isn't inevitable. It's a matter of choice.
And action. Because it's not just about saving polar bears or protecting rainforests. It's about preserving the web of life that we ourselves depend on. Pollinators, clean water, stable climate, biodiversity. Our survival is entangled with theirs.
And there are people fighting back: conservationists, scientists, local communities, protected habitats, breeding programs, marine reserves, rewilding efforts.
And some success stories, like the California condor, the Sumatran rhino, and the gray wolf. It shows that when we intervene with care and purpose, nature can rebound.
So the question isn't just, are we in the sixth extinction? It's, what role will we play in it?
We can be the destroyer or the steward, the asteroid or the guardian.
And that brings us full circle, because extinction isn't just ancient history. It's not locked in fossils or museum exhibits. It's now.
It's happening in the forests, the rivers, the coral reefs, and the choices we make today will echo through time.
So what will the fossil record say about us? That we consumed without care? Or that we chose a different path? Or will we be the first species to analyze its own end?
The sixth extinction is still being written, but unlike the others, this one has an author.
And that author is us. So what have we learned, walking through the ruins of 5 lost worlds, and one that may still be saved?
That life is resilient, but also fragile. That extinction comes not just in fire and impact, but in silence and slow erosion. And that we are not immune to the laws of nature. We are participants in them.
Each extinction changed the world, not just by ending species, but by opening space for what would come next. Trilobites vanished, but vertebrates rose. Amphibians fell, but forests spread. Dinosaurs ended, and mammals began.
And now we stand in a moment where the outcome is not yet decided. The sixth extinction looms, but it's not written in stone. Not yet.
Which means we hold something no other species has held before: foresight. The ability to see what's happening and choose what to do about it.
And that makes us more than just witnesses. It makes us authors of the next chapter.
So let's write wisely. Let's learn from the fossil record, from the stars, from the silence after impact.
Let's remember that extinction isn't only about death, it's about transformation. And if we choose to act, if we choose to care, we may yet become the caretakers of a world that continues to thrive. A world richer in life than we've ever known.
One where extinction is not our legacy, but our turning point.
Because these stories don't end here. In the next episode of The Lantern's Glow, we'll continue exploring the threads that connect us all, from ancient life to cosmic possibility.
Until then, all is one.
Thank you for walking with us through deep time. We've seen worlds end and life begin again, not once but many times. From silence to song, from ash to flight, from extinction to evolution. And now, we are the ones with the pen in hand. But this story, the one you've just heard, doesn't end here. It echoes in every coral reef, every ancient fossil bed, every warming current, and it continues through you. So if something in this journey stirred your thoughts, if it lit a spark, then stay with us. Leave a comment. We do read everyone. Your insights, reflections, and questions help shape the path ahead, not just for this channel, but for our long-term vision. Like, share, and subscribe to help keep this flame alive and to help bring others into the light. Share this episode with someone who needs to remember what life can become, if we choose to protect it, because the flame we carry isn't just knowledge, it's memory, and maybe, just maybe, a glimpse of what we could still be. From the ruins of 5 lost worlds, and a 6th still unfolding, we will keep tracing the threads that connect us all. This is The Lantern's Glow, and I'm Albert. Until next time, stay curious, stay kind, and keep the flame burning. All is one.